Okay, I'm going to give you an example of how to draw surface currents on a made-up world. Your global wind patterns are the blue arrows to the left here. So this would be our northeast trade winds, southeast trade winds, etc. So we need to use those global wind patterns to figure out which way our water is going to go. Remember, due to the Coriolis effect, water in the northern hemisphere is going to be deflected to the right of the wind. In the southern hemisphere, water is going to be deflected to the left of the wind. And we're going to look at the very top of the surface currents, so our water is going to be deflected by the magic number of 45 degrees. Okay, so I'm going to use green, just so we're not confusing that with the red for warm and the blue for cold. And I'm going to kind of sketch my ocean direction on the outside here, because we need to use these arrows to figure out where 45 degrees is. So for this first arrow, since this first arrow, I'm going to work on this one, is pointing down towards the bottom of your page, it would be easiest if you flipped your page upside down so that the arrow is actually pointing up, so you can see the correct orientation of the water moving to the right of the wind. So 45 degrees from this arrow to the right would be this direction. So all my water between 0 and 30 degree latitude is going to be moving this direction. It's going to move that way, and it's going to start to turn, especially once it hits land. Which way is it going to turn when it hits land? It's going to turn to the right because we're in the northern hemisphere. That means it's going to move up. Now, while it's moving up, it's going to enter a new global wind pattern system. And the Coriolis effect, remember, takes about 6 miles to take an effect. This is definitely more than 6 miles, so my water is going to start to turn. Which way is it going to turn? It's going to turn to the right. So it's going to go this way. It hits land again. That's going to force it to turn to the right, so it's going to come back down. If I go a little farther north, up into the polar regions, I'm going to take a look at this polar easterly wind. My water should be going that direction. It's going to hit the land, it'll turn right, so it's going to go this way around the globe, and it will come back. I guess I forgot to do this arrow. 45 degrees to the right would be that direction. So double check to make sure your water is matching the wind and the Coriolis effect. Okay, moving to the southern hemisphere. Remember, our water is moved to the left by 45 degrees since we're in the southern hemisphere. So to the left of this arrow would be that direction. It's going to strike land, and since we're in the southern hemisphere, it's going to get deflected to the left. Now that it's traveled for a while, to the left of that arrow, remember it's upside down, so you have to flip your paper around to see it. It's going to go this way. It'll strike land, go to the left, so it'll come back up. This southern polar easterly wind is going to move the water towards the west till it strikes land. It'll go around the globe and then come back. Now let's think about temperature. Temperature for water, remember, it changes very slowly. So let's just focus on the north and south flowing currents. Remember, the equator is where a lot of our water is absorbing a lot of energy. So it takes a lot of energy and absorbs it as it's moving along the equator, and then this up arrow should be, what color do you think? It should be warm, therefore red, because that water spent a lot of time at the equator warming up, so now it's nice and warm. It has a high specific heat, which means it doesn't cool down very quickly, so it's going to stay warm as it moves north. And like I said, I'm not going to worry about the left and right arrows. Let's just focus on the up and down arrows. Now that the water's been up here for a while, it's losing its radiation, it's losing heat, so our water is going to cool down. So our south flowing water should be blue. Up in the polar easterly region, it is going to be losing radiation, so it is also going to be blue. Wrong tool. And then we can do the same thing for the southern hemisphere. It's going to warm up all along the equator. Then when it travels south towards the South Pole, it's going to take, oops, wrong color. It's going to take its heat with it. And then it cools down when it's up at the 60-degree latitude. Now my line's not erasing. Here it goes. So it's going to be cold coming up. And in the South Pole region, it's going to be cold. So it will be blue. So this is what our ocean currents would look like in this made-up world. So now you're going to have to do the same on another example. So in this example, I want you to draw the surface currents. Remember, water is only going to get deflected if it really strikes land, if it's moving east or west. So pay attention to the land and see if it strikes the land and then thus will get deflected or not.